Okay, so in this video we're going to integrate trigonometric functions. Alright, so the first thing we're going to look at is what's in the logbook. So what's in the logbook with regard to this is these three. So if we're integrating cos x, it will become sine x. And if we're integrating sine x, it will become minus cos x. And this here, well, you don't need to worry about that, okay, because you wouldn't get that in the exam. Alright, but I suppose just to say, if we're integrating tan x, well, that would become the natural log of the modulus of sec x, right? But don't worry about it. Now, this is not in the logbooks, and this is what you really need to know, is that if we're integrating cos x, but some number in front of the x, well, what happens is, we will integrate, just pretend it's cos x, okay, so that will become sine x, but we'll keep the number here, and then as the denominator we will have that number. Alright, and that will make more sense when we do the question. And the other one here is, if we're integrating sine of some number x, well, we'll integrate sine x and it'll become minus cos x, put the number in, and then use that number as the denominator. Okay? Okay, so this was a little bit different because we have a minus in front of the sign. Now if we have a minus, or indeed a number, if we look down here, there's a number in front of the cos, what we do is we just take that out. Okay, so watch this. This would become minus, and now get rid of that minus so it's outside the bracket, and then we can integrate the sine 5x as normal. This minus, I can also say it's a minus 1. Right, so just think of that as a minus 1 sine x, so get the minus 1 outside the bracket and integrate then the sine 5x as normal. And if we integrate the sine 5x as normal, it'll become minus cos x, and then put the 5 before the x and the 5 below. And then of course our plus c. And we can simplify that a bit further because we have a minus 1 outside and we have a minus cos inside. So if we multiply what's inside by minus 1, we get cos 5x over 5 plus c. Okay. The same with question 5. We have a 3 that's kind of before the cos 6x. So again, get it outside the bracket. So 3. And now we can integrate our cos 6x. So let's give myself a bit of room. So because, integrate the cos and we will get sine, so it'll be sine 6x over 6 plus c. Okay. And just following on from that, we can simplify it a bit more. Okay, so we have a 3 here. If we multiply it all by 3, well then we get sine 6x over 2 plus c. Alright. The next one then, we have it in 2 bits, but don't let that confuse you, okay? Just work it out bit by bit, right? So we'll take this one first, the cos 2x. So cos 2x will become sine 2x over 2. And then we have sine 5x, we're going to have to take the minus out. And then sine will become minus cos, and it's a 5x, so 5x all over 5 plus c. We can simplify it a bit. We can say sine 2x over 2 and then plus cos 5x over 5 plus c. Okay, I'm just dealing with the two minuses there. Okay, so that's that one done. So the next one then. Okay, so we have an exponent one here. So check back in the videos if we're confused with that and look at your logbooks. We'll take the 4 out and then we want to integrate the e to the 2x. So we take our e to the 2x and multiply by 1 over, and it's 1 over the exponent differentiated, which is 2. Okay, and that can be changed to e 2x over 2 plus, okay, and again it's a 4 here, so that's handy, so we can just leave the same 4 outside. We don't have to make another bracket. And we want to integrate sine 3x, so that would be sine integrated is minus cos, and it's 3x, so it's 3x over 3, close our bracket, plus c. Personally, I'd leave it like that, right? Back of the book says this. Yeah, they simplified a bit more. Personally, I like it like that. But the back of the books did this. It multiplied the 4 by the e to the 2x, and it got 2 e to the 2x, and then plus, and I brought the 4 out here, minus cos 3x over 3, close the bracket, plus c. Okay, so it basically took this on its own, and then it had the 4 and in brackets minus cos 3x over 3. That's the way the back of the book says it. Personally, though, I think this is nicer. Okay, so I would leave it like that. Right, the next one. So in this one, well, in question 7, right, we had, if you look here, we had the 4 and the 4, so we could use 1 4 outside and put all the rest in brackets. However, with this one, we have a 3 here, and we have a 2 here, so we're going to have to put 2 sets of brackets, right? But that's no problem. Okay, so what we have here then is we take out our 3, and cos x integrated is sine x, and then we have minus 2, we take that out, and cos 4x integrated is sine 4x over 4 equals to plus c, and we can simplify that then to say 3 sine x minus, and we've got the 2 up here, so 2 sine 4x over 4 plus c, and we can simplify it even further. We could say 3 sine x minus sine 4x over 2, just dividing top and bottom by 2 here, plus c. Okay, so question 9 then. Question 9 is a bit of a strange one, right? But let's work through it anyway. So it says if y equals sine 3x squared, find dy dx first. Okay, so we're differentiating there. So y equals sine 3x squared. Right, so we're using chain rule. So if we differentiate the sine, we'll get cos 3x squared, and then we multiply that by, and we take this bit and we'll differentiate that, and we get 6x. So dy dx equals 6x cos 3x squared. Okay, so that's our first part. We differentiated. The second part then, hence find the integral of 6x cos x 3x squared. Or, sorry, 3x squared dx. Okay, now remember I said to you, we would not be expected to be able to integrate this, right? It's too tricky because it's two things multiplied together. So I wouldn't be expected to do all that out, right? In a question like this, all I'm expected to know is that integration is the opposite of differentiation. Right, so all I have to say here is this. 6x cos 3x squared dx, when that's integrated, it comes back into sine 3x squared, which is this. I just have to know that by integrating it, it undoes the differentiation, but remember I have to put in the c, okay? And that's that. Okay, it's a little bit silly question really. All you really need to know is when you differentiate something, if you integrate your answer, you get back to the original function. Right, so this one, as I said, to look at it first, you would be thinking, oh, something to do with chain rule here. But remember, we're not expected to be able to, I suppose, have the knowledge of integrating things with chain rule. So if you were to get something like that, you think, okay, well, I'm obviously going to multiply it out first. Right, so ex minus e minus x multiplied by ex minus e to the power minus x dx. And if I multiply this by this, this by this, this by this, and this by this, I will get, well, I'll do it out, we'll get ex all to be squared, and then we have minus e to the power of minus x multiplied by e to the power of x. Okay, so that's, I'll show you that. So it's that by that, and then that by that, plus, and then we'll multiply this by this, and again we'll get, it's actually minus e to the power of minus x multiplied by e to the power of x, and then this by this will be plus e to the power of minus x multiplied by e to the power of minus x. Okay, that looks pretty messy, right? But we get there. So we have the integral of e x all to be squared is e to the power of 2x, okay, your rules of indices. And if we look at this bit, we have minus e to the power of minus x multiplied by e to the power of x. Okay, let's have a look at that. So when we're multiplying indices, we add the power. So if I was to add this and this, so minus x and x, well, that's a 0. So that will be minus e to the power of 0. And then up here, well, we have the same. We have minus e to the power of 0. And then plus e to the power of minus x multiplied by e to the power of minus x. We add the powers. Okay, so add this and this. So we get e to the power of minus 2x. Right, so I'll just rewrite that up here to give myself a bit of space. So we go integral of e to 2x minus e to the power of 0 minus e to the power of 0 plus e to the power of minus 2x. Well, anything to the power of 0 is 1. Okay, so it's e to the power of 2x, and minus e to the power of 0 is minus 1, and minus e to the power of 0 is minus 1, plus e to the minus 2x. And simplifying that, then we get the integral of e 2x minus 2 plus e minus 2x. Okay, so now we have it simplified, multiplied out and simplified as much as we can. So there we go. We still have to integrate that. Okay, so let's integrate it. Okay, so if we integrate e to the 2x, it'll become e to the 2x over 2 minus 2, well that will just become 2x, and then plus e to the 2x, sorry, e to the minus 2x all over minus 2 plus c. Okay. And personally I'd leave it like that. Alright, next one, again, to look at it straight off, you would think product rule, because there's 2 be multiplied together, but again we can't integrate with product rule, wouldn't be expected of us, but we will multiply out the brackets. So if I go this by this, this by this, this by this, and this by this, I would get, let's see, 6 plus 3 e to the minus x plus 2 e to the x plus e to the x multiplied by e to the minus x, and I should put in the dx really. That will give me 6 plus 3e to the minus x plus 2e to the x plus, well, if we're multiplying, and it says we add the power, so it'll be e x minus x, so 6 plus 3e to the minus x plus 2e to the x plus e to the power of 0, and anything to the power of 0 is 1. Okay, I really should be putting in my dx's the whole way down. We just come over here. 6, actually no, 7, because 6 and 1 is 7, plus 3e to the minus x plus 2e to the x dx. And now I can integrate that. So that would become 7x plus 3e to the minus x over, and it'll be over minus x integrated, which is minus 1, plus, and then we integrate this, and it'll be 2e to the x all over x integrated, which is 1, plus c. And we can simplify this a bit. We could say 7x plus, sorry, minus a, because we have a minus 1 here. That's minus 3e to the minus x plus 2e to the x plus c. And we can even simplify it a bit further. We can say 7 minus 3, and e to the minus x will be 1 over e to the x plus 2 e to the x plus c. Okay, and I leave it at that. Right, so there is our answer. Okay. Again, if you got to here, okay, you'll be doing pretty good, but you know, just simplify it a small bit. Right. Okay. Last one then. Looking at this, you'd be thinking straight off, maybe, quotient rule, kind of has a resemblance of quotient rule, but remember we wouldn't be expected to integrate anything to do with quotient rule. So we'll use our rules of indices. So if I had, let's say, 3 to the power of 4 over 3 to the power of 2, well, if we're dividing indices, that would become 3 to the power of 2, because we minus the powers 4 minus 2. Okay? So we'll do likewise here. We'll rewrite it. So e to the power of x plus 2, and then we're going to have e to the power of x, and we'll minus the power, so that'll become e to the power of x plus 2, which is on top, but then we minus the x on the bottom. Okay, so that'll be that bit done. And then we have, concentrate on this bit, we have the 3 and the e to the x. Well, what we can say here is plus 3e, and we'll be bringing that 3e up, so it'll become 3 to the minus x. Okay, we're minusing the powers really. dx. Simplify that. E to the x plus 2 minus x is just e squared plus 3e minus x dx. Okay, so now we're going to integrate e squared. Now think of this, e squared. Remember, e is just a number. Okay, so if I was to say integrate 4 squared, well, that would be x 4 squared, or another way of saying it, 4 squared x. Why would that be? Well, if I was just integrating 4 on its own, it would be 4x. Or another way of saying it, if I want to integrate 4 squared, right, I can say it's 4 squared x, okay, which will give me 16x. Have a look at it this way, if we just take that down, 4 squared, well, squared out at 16 and now integrated 16x, so same answers. Okay, so don't think of e as anything other than just a number in this instance. So e squared will become e squared x, okay, and we can just say x e squared if we want. Okay, there's no difference in e squared x or x e squared. Right? I'll leave it like that. Okay, and then if we integrate this, we'll take our 3 out, and we'll have e to the minus x, so it'll be e to the minus x, and minus x differentiated is minus 1, okay, plus c. And the next bit is just simplifying really, so e squared x plus 3e minus x over minus 1 plus c. So simplifying a little bit then, e squared x plus, get rid of that minus 1, so it'll actually be a minus 3e minus x plus c. And this here, this e to the minus x, I can simplify that a bit. I can say e squared x minus 3 e to the x, or 3 over e to the x plus c. Okay, and that's that really. Okay, so that's it guys, and as I said, usually with this kind of stuff it's just practice, 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 right? But that is now as tricky as you're going to get, right? So if you can do that, you're doing pretty well. Right, thanks guys.